Assalamualaikum warahmatullahi wabarakatuh. My name is Damia Shadia binti Ahmad Azwan from Group 15, Part 4. Today, my group will presenting the topic about nuclear fusion-fission hybrid reactors. Let's move on to the introduction for my group members. Before we move on to our presentation, let me introduce you to my group members. The first one is me, Damia Shadia. The second one is Alfa Farzana, Nur Farhani, Fatin Zulaika, and Aida Maisar. So, what exactly is fusion-fission hybrid reactors? To make it simple, it's a system that combines a fusion reactor with a subcritical fusion blanket. It uses a high-energy neutron from the fusion process to drive fission in fuels like uranium-238 or thorium. This makes energy generation more efficient and helps in burning nuclear waste. We also provide you a video of how the fusion-fission hybrid reactors work. Next, we are diving deeper into the world of fusion-fission hybrid reactors. The reason we chose this topic is because it is deeply rooted in core concepts of modern physics. It is not just theoretical, but it also connects directly to active research areas. More importantly, this technology shows how theoretical physics can be applied to solve real-world challenges. As global energy needs evolve, physics plays a critical role in addressing these global issues. Next, to ensure our findings are accurate, we used a comprehensive methodology. We gathered the data from scientific journals and academic publications for peer-reviewed theories. Next, we use online databases and industry websites for the latest technical data. And lastly, we use reports and news to stay updated of the current state in our industry. Now, let's move on to the next part. Innovation isn't without its hurdles. We've identified the four main challenges that we encountered. The first one is physics. It is incredibly difficult to maintain a steady state operation for months at a time. The second one is material science. High energy neutron damage components leading to frequent shutdowns for replacements. The third one is operations. Because of the radiation, we need advanced robotics to handle and maintain the system. And the last one is security. Breeding fissile materials requires strict international monitoring to ensure safety and non-proliferation. Before I pass the presentation to the next person, here come the proposed solutions. We proposed three strategic solutions, which is the first one is economic strategy. For economic strategy, we should collaborate with private fusion startups and government labs to share the financial risk and fundings. Safety protocols, which is the second one, we must develop specialized safety standards that handle both fission containment and high energy plasma management simultaneously. And the last one is advanced engineering. By using modular reactor components, we can build the fusion and fission section independently. This will make the construction and maintenance much easier.
Now, I will explain the concept and theory behind nuclear fusion-fission hybrid reaction. But first, we need to understand what is nuclear fission. Nuclear fission is process of combining two light nuclei to form a heavy nucleus and release large amount of energy during this process. So one common example is the fusion between deuterium and tritium, which are isotopes of hydrogen. In this process, it produces helium, neutron, and about 17.6 mega electron volts of energy. So fusion is extremely important because it's the same process that powers the sun and other stars. So scientists believe that fusion could become a future clean energy source because it produces very high energy with very low greenhouse gas emission. Next, I will explain about nuclear fission. So nuclear fission is a process where heavy atomic nucleus split into smaller nuclei after absorbing a neutron. In this reaction, from the example we see, the uranium-235 combine with neutron and become unstable. It then splits into barium and krypton while releasing additional neutrons and a large amount of energy. This released neutron can continue splitting other uranium atoms and creating what we call as chain reaction. So this concept usually we use in nuclear power plant to generate electricity. So compared to fossil fuel, nuclear fission it produces much lower carbon dioxide emissions. However, it also produces radioactive waste, which we must manage carefully. So after we understand fusion and fission reaction separately, now we can look at the hybrid reactor system. So nuclear fusion and fission hybrid reactor system is combined both high energy into one system. In this reactor, fusion reaction generate high energy neutrons, and these neutrons are then directed into surrounding layer called fission blanket. And the neutron trigger fusion reaction in materials such as uranium or thorium, producing additional energy. So this combination allows the reactor to produce more energy efficiently compared to using fusion or fission alone. So from real-world example, we have the ITER project, that is one of the world's largest nuclear fusion research in collaboration that involve many countries such as France, China, United States, Japan, and Russia. Hybrid reactor offers several important advantages such as higher energy efficiency, reduced radioactive waste, better fuel utilization, and lower carbon emission. This technology may also improve long-term energy sustainability for future generations. However, hybrid reactors also face many challenges, such as the technology is extremely complex because it combines two advanced nuclear systems together, and the development and construction costs are also very high. So another major challenge is maintaining stable plasma for fusion reaction. High radiation level may also damage reactor materials over time, and currently hybrid reactors are still mostly in research and extreme experimental stage.
Now I will talk about the applications of nuclear fission, nuclear fusions, and the reactors hybrid in daily life. First, in the medical field, the nuclear fissions produce a radioactive material called radioisotopes that are very useful in the medicines. These radioisotopes are used in the medical scans to help the doctors detect diseases and also in cancer treatment to destroy the cancer cells. For example, radiation from certain isotopes can target unhealthy cells without any major surgery. Next, the nuclear fission is considered a future clean energy source. Fission produces energy by combining small atoms like hydrogen and releases a very large amount of energy. Unlike fossil fuels, fission does not release harmful gases such as carbon dioxide and produces less radioactive waste. Because of this, scientists believe that fission could become a clean and sustainable energy source in the future. And lastly, hybrid reactors helps with waste reductions and more efficient in energy production. In hybrid reactors, fission reactions help reduce the radioactive waste produced by fission reactors. The high energy particles from fission can break down long-lasting nuclear waste into less harmful materials. This can make the nuclear energy safer and reduce environmental problems. Besides of their applications in daily life, the nuclear technologies are also improving in the modern and innovations. First is a successful fission experiments. Scientists have recently achieved fission reactions that produce more energy than before during the laboratory experiments. This shows that the fission energy has a strong potential to become a future clean energy source. And second is the development of advanced reactors. New technologies such as small modular reactors, which known as SMRs, and hybrid reactors are being developed to improve reactor safety, efficiency, and energy production. These reactors are also designed to reduce radioactive waste. And one major controversy is the high cost of building and maintaining the nuclear reactors. Nuclear projects require advanced requirements, skilled workers, and long construction periods. And lastly is the dependence on AI technology. If the AI system fails and makes incorrect decisions, it might affect the reactor safety and operations. It may also reduce human control and critical situations if the nuclear systems rely on AI and automated technology too much.
Now, I will talk about potential careers related to nuclear fusion and fission hybrid reactors, as well as the important skills needed in this field. First, one possible career is a nuclear physicist. A nuclear physicist studies nuclear reactions and works on improving reactor technologies. They help develop safer and more efficient ways to produce nuclear energy. Another career is a radiation protection specialist. This person ensures that workers and the environment are protected from harmful radiation. They monitor safety levels and make sure all procedures follow strict safety standards. Third is an energy policy analyst who studies the impact of nuclear energy and helps governments plan better energy policies. To succeed in these careers, several important skills are needed. First is a strong foundation in nuclear physics and engineering, which helps us understand how nuclear systems work and how energy is produced safely. Second is problem solving and analytical thinking, which helps professionals handle complex challenges and make good decisions based on data. Lastly is computational and simulation proficiency, where scientists use computer tools to model and test nuclear systems before building them in real life.
Why is continuous safe development so vital in modern physics? First, technologies like hybrids and fusion reactors are evolving at a breakneck pace. To stay relevant, we must be lifelong learners. Secondly, safety is paramount. We must constantly update our knowledge of international safety protocol to ensure zero-error operation. Essentially, constant growth is the only way to remain competent in such a high-stake industry. Nuclear physics isn't easy. The main challenges are the extreme complexity of the theories and the high cost of research facility. Furthermore, we face public stigma regarding the safety of nuclear energy. To overcome this, our strategies include collaborating with international research bodies to share resources. We also need to be better science communicators to educate the public that modern nuclear technology is both clean and safe. With this step, we can bridge the gap between complex science and the sustainable future.